Hello everyone and welcome back to another beat 'em up game tutorial. I know it's been a little while, but I'm still trying to keep this series running for you guys so that you can create your own beat 'em up games. And so today, we're going to be working on more of the level design aspect. So I'm going to go over how to make a very simple camera. As you can see, we have this camera moving around. I'm also going to help you I'm also going to make a wave system. So most beat 'em up style games have this sort of wave system. This is the system that my beat 'em up game uses, Karam and the Worldwide Street Brawl. So this is going to be the very same system as that. And basically what happens is you have some enemies. While enemies are on screen, you are going to be stuck within the bounds, the camera bounds. So it keeps the action focused here. And then you can just sort of fight them. And once all the enemies are done off screen, then that wave is finished and you can once again continue forward in the level. And so we're going to be going over how to make that. Also with this wave system, there will be multiple waves, so you can defeat. So I just defeated one guy and then another guy spawned. We're on the second wave right now. I can defeat this guy. And now another guy spawns. And so it's multiple waves kind of dealio, and you can just keep on moving on and sort of create very simple beat 'em up style levels with this. So that is how we're going to do it. That's what it's going to look like. Let's get right into making it. So the first thing we're going to do is we're going to make a few room changes. So over here on the right in our asset tab, the first thing I did was I created a new blank room called rm_persistent. Now I have a single object in here, but that object doesn't exist yet. We need to create that. So don't necessarily worry about adding that in. All you need right now is rm_persistent if you don't have it already. Next, this is the room we were testing before, room 1. So I did make a few changes to this. This stuff right here, where you have the enemies and this wave starter object, I'm going to go into that in a bit more detail later. But for now, all you really need to know about what I did was I expanded the room's length. Mine specifically is now at 5,366,768. You can make yours however big you want it to be. It doesn't really matter. This is just what I chose for mine. So I just lengthened the room. Another thing I did is I put this sprite in the background. That's just this sort of grid size. This is backgrounds 2. All I did was create a very simple sprite called SBR background. That's just a square with colored edges. And then I made it horizontal tile and vertical tile. That's just so that while we're moving around the room, we can actually see the camera doing its job. So that's the bulk of the changes that I've made to our room 1 here. So let's go into what we're actually going to be editing here. So basically, the way I wanted this system to work, I've seen other wave spawners where basically what it does is it stores a bunch of enemies in an array, and then you have to store the coordinate points for where you want them to spawn in the room. For my system, I didn't want to have to go into the room, figure out oh, okay, this is 1327 by 575, so I need to put that and I need to save that. I didn't want to have to work with coordinates. The way my system works is you can place all of your enemies in the room, and then from there, the game will remove them and only put them back in the room when it's time to start the wave. So let's go into how that system works. So over here on the right, we're going to be adding a few things. So let's go ahead and start with the camera. So for this camera object, it doesn't need a sprite, but I gave it this little sprite just so that we know what it looks like. This isn't going to be visible in the room, so in the draw event, I left it clean. But you literally don't have to put a sprite here. That's just something I did. So, in the create event, we're gonna set this up. So we're gonna make a new camera. So every time we use this camera macro, it's gonna be referring to view camera 0. This is basically it's similar to a variable, but a little bit different. So this is the cam width and cam height. So I put it to 1366 by 768. This is the full screen variable. If you want to full screen it later, I've set it to false. I'm not really going to be going over how to full screen your game right now, but it's very, very simple. So this sets the camera size, basically the resolution of the game. So camera set view size, our camera that we want to use, and our cam width is going to be equal to that. Our cam height is going to be equal to that. Surface resize. So this is, I'm not going to explain cameras a whole lot here in this tutorial because there are better tutorials that do it better. So I recommend like the Pixelated Pope's camera tutorials for that. He has a very good series about that. But this just resets this resizes the application surface so that the resolution is the same as the camera size. That's all that does. And then this is the GUI size. So when you're using the GUI drawer, this is the resolution for the GUI drawer. So I just set that to the cam width and cam height. Basic stuff. This part is probably the most important. These two parts probably don't matter as much. Those are just kind of very small, subtle detail things. Alright, window size. So this just sets the window size to cam width, cam height, and then we center the window. That's all that does. So, sorry about that. We're going to set up a function here, and it says update battle bounds. So basically what this does is when the player runs into a wave starter, the camera bounds are going to be locked in place, and that's where the player is allowed to be in. So as you can see, global.backBounds is equal to x, and global.frontBounds is equal to x plus cam width. So I'm going to go into more detail about what these are a little bit later. And then I've also set up something else. So this is SCR underscore point in camera. So basically this is just going to check if something is inside the camera bounds. So it says point in rectangle underscore x underscore y, whatever we pass in. And this will be x and y is going to be the top left corner of the camera. And then x plus cam width, y plus cam height, that's going to be the bottom right corner of the camera. So I'll just tell us like, okay, such and such point is inside the camera. And then it'll return true if true, and it'll return false if false. Easy as that. Alright, step event. So the first thing we're going to do is this code here will crash if the player object doesn't exist. So first we're going to make sure, does the player object exist? If it does, yay. So if global.locked in place. So locked in place is when a wave starts, this is going to lock the camera in place so that it's going to lock the camera in place along the x-axis so that it doesn't move left or right anymore because we want it locked, you know, in the center basically. So what we're going to do is our targ x is going to be equal to obj underscore player.x minus cam width divided by 2. So basically this will put the player's x in the center of the camera. And then we're going to do x equals lerp x underscore targ underscore x 0.25. So basically what this does is this gets a point 25% between my x and targ x. And what that'll do over time is it'll kind of sort of like a slowly pan to where the player is. I do it this way just so that the camera has a bit of sort of an animation to it. Like it doesn't stick to the player. It sort of allows the player to move around a little bit. Like as you can see, if I stop moving, the camera sort of like comes towards the player's position. If you see that. This line isn't necessary. You could just go in and do underscore targ underscore x. So what would that look like? That would be just like the x is always equals to the player's position. So as you can see, in this case, the camera doesn't really move at all. There's like no subtle movement. The player is always stuck in the very center of the screen constantly. So, those are the two ways to do it. You can do it whatever way you want. That's just something that I like to add to camera just to give it a little bit of life. So, what does this do? So, clamp to the backbound so the level always moves forward. So basically what this does is when we set up backbounds, our X can't go under that value. So basically what that means is that if you've ever played Castle Crashers, once you start a wave, you generally can't go backwards. The camera doesn't pan left, and the player can't go past the camera bounds. So basically this is mimicking that sort of same system. You can see that when you play my game as well. If you encounter a wave, this backbounds is going to set, okay, what's the leftmost limit that the player and the camera can go. So that's what that does. X is equal to clamp X room width minus cam width. So basically what this does is like, okay, irregardless of backbounds, like ignoring this, this makes sure that the camera never goes outside of the room to the left. So the camera is always going to stop here. And this also makes sure that the camera won't go off the screen to the right. So the camera is always going to stop here. So remember, X being the top left corner, so the left bounds of the camera can't go past 0. And this gets the right bounds. Cam width is basically the right bounds, so like this makes sure that it can't go off the screen to the right. Simple as that. Alright. This is vertical movement for the camera. It's basically set up the same way we do the x-axis, except I didn't feel a need to lock the y-axis. You could if you wanted to. I really don't feel like it's necessary, because then we can do things like when the camera is locked, as you can see here, we'll still be able to move up and down. Except my room is exactly the size of the camera, so basically all of that won't be noticeable. Alright. So that's sorted. What else do we need to do here? Alright, camera set view position. This sets the camera position, and we're just going to set it to my X, my Y, so that it remains where it needs to be. And then this here is full screen. This just says if you push VK11, window set full screen. You don't need this. I don't really think it's that important. But you could add it in. When you're making games, some people are going to have smaller monitors than you. So what seems like a good window size might actually be too big or too small in somebody else's monitor. So generally in a full release of a game, I like to make sure that this full screen option is available, so that if the resolution is too small for somebody, they're still able to play the game. But that's just me, and that's just my consideration. Alright, room start. So, room start. Basically, when the room starts, we have to set up the room for cameras. So we have to do view enabled true and view set visible camera to true. So basically, this will turn the camera on. This will tell the room like, okay, we're using a camera in this room. The next thing we're going to do is we're going to make sure that the global.front bounds is equal to room width. So remember, we don't want to limit the player's movement at the very, very beginning. We want them to be able to go as far right as they possibly can. That way they can go ahead and activate waves and things. So that's what we want to set up there. And then the draw event, you don't actually need this event if your camera doesn't have a sprite. Since I added a sprite to my camera, but I don't want that to appear in game, I just want that to appear on like this thing so I can see what this object is. I just put in an empty draw event, which means that the camera won't draw. Well, the sprite won't draw. Alright. That should be the camera. So, once you are done with the camera, go ahead and move to room 1. and just place it down in the instances layer. Actually, no. I put it here in controller objects. That's a good space for it. I created a new layer called controller objects. You can put that here. It's not necessary. You could put it in instances too. I generally just like to separate things on different layers because then it's more easy for me to access. Like, oh, okay, I know this is going to be on the controller objects layer, and if I'm coming in and deleting everything on this layer, it won't interact with the camera object, which I need here. So that's how that works. Camera, done. So we need to set up a few global variables. And the best way to do this is to set it up in a script, because scripts always run before objects. So as you can see, I have this script called config. And what I use config for is to set up a bunch of things that I don't want to mess with later, or that I want to mess with specifically later. So this is where I keep all my macros. This is where I keep all my globals. So as you can see, I've set up back bounds and front bounds here. I've just initialized them to 0 right now. There's nothing important about that. And then here's the locked in place, false. All of these variables we're going to be using later for our system. Then you'll probably notice hashtag macro boot room is equal to room 1. So you're probably like, well, what's all that about? So remember how I told you guys to create a persistent object? A persistent room? Well, what's going to happen is I like to use persistent rooms to hold on to all of my objects that are persistent. And I'll explain more detail what persistence is, but basically persistent objects basically, they don't get unloaded when the room they're in gets unloaded. Generally, I like to keep them in one room so that at the very start of the game, we go to the persistent room and then we go to the rooms we are going to use. Most of my games work this way. It's like an invisible little trick just to make sure that some of my most important objects are created and exist before everything else. So the issue with our wave manager that we're going to make a little bit later is it needs to exist before all the other enemies. Otherwise, some enemies won't get removed and added back in the way they should be. So to combat this, I create a persistent room. I changed the room order so that the little house icon is next to the persistent room. You can do that by clicking and dragging on these lines on the side here. And then what I have is if you click on creation code here, like click here on the tab, and it should come up creation code right here. So this just says room go to boot room. So basically what this does is as soon as you load this room, it'll go to the next room, whatever boot room is set to. And because I have my config set up, so boot room is equal to room 1, that means we immediately go to this room. Simple stuff. That's all that for this. Alright, so now our camera should be working if you enter into the room. However, none of the wave stuff is going to function, and all this back bounds and front bound stuff is not going to be functioning either. So now let's go ahead and go to the enemy manager. So basically how this system works. What we're going to do is we're going to look at every object in the room. We're going to save what kind of enemy they are, where they are, their X and Y, and what wave number they're supposed to spawn in on. And then we're going to delete them. And then when it's time to create a wave, we're going to pull from the data we've stored and basically put that object in the room. So it sounds a little bit scary, but we're going to walk through it. So first we need to be able to store the enemies. So we're going to create this all enemies array, just like that. We're going to set up a lock camera boolean here. We're just going to set that to false. You don't need to worry about it right now. Alright, store all enemy data. So with obj underscore enemy parent. So you shouldn't have that set up yet. I'm going to explain this part and then we'll set up the obj underscore enemy parent. So with this stuff, so basically we're going to set up a struct. So what this will do is for all enemies in your game, every instance of an enemy, we're going to store some data for that enemy. So my data is equal to a struct. So we're going to store our object index, so what object we are. We're going to store our x, our y, and our wave number. This I'm going to explain when we set up enemy parent. Basically, the way I have it set up is so that enemies store what waves they want to be on in themselves. So I'm going to explain how that works. And then array push. So basically, this will store all of our data in a struct for later use. We're going to put it into this array that we set up earlier. And then we're just going to destroy this object. So like we set it up in the room by hand, but we're going to instantly destroy it so that this enemy manager can create it back in. Alright, reset values. So this will set up a bunch of the variables we need. And because we're going to be using this object a number of times, we're going to want to be able to reset all of these values multiple times. So wave active, false. Current wave, 0. Last wave is equal to current wave. Wave is equal to an empty array. And then active wave is equal to false. And then reset values. So these are a bunch of variables that we are going to need later. So room start. What does room start do? Room start basically does the exact same thing as our create. It stores everything in an array, and then it resets the values. So as you can see, it's a little bit simpler here. But basically, whenever we start a new room, like this enemy system, we can use it for multiple rooms. Whenever we start a new room, this is going to run. And this code is actually important because if you remember, when this is created, it's going to run in the persistent room, and there's no enemies in the persistent room. So if we didn't have this room start event here, nothing would happen when we load into our room. Alright, step. So first, we need to check if there is a wave active. Obviously, if the player is like walking between two waves, then we don't want to do anything with this. So, if active wave, what we are going to do is we're going to loop through all the enemies in our array. So we're going to loop through all of them. So, this just takes out a single enemy one by one. So if you remember, this variable right here, it's going to be storing the enemy X and Y from when we put it in the room, and its object indexed, and its wave order. So as you can see here, what we're going to do is we're going to check, like, okay, is this point within the camera bounds? Is this point within the camera bounds? If it is, with our wave array, we're going to push this struct in, so that we know, okay, like this is one of the ones that we need to add. And then once we have transferred the enemy from this array to this array, we're just going to delete this value from the all enemies array. So we're just going to remove it. Easy as that. Then we only want to do this once. So we're going to say activate wave is equal to false. This is like the setup for the wave. And then wave active is equal to true. Last wave is equal to -1. So this is just going to store like, okay, now it's time to actually start spawning things in. Now that we have set up, we know what's supposed to be in this wave, we're going to start spawning it. So basically, like, simple as, this is just going to check, like, okay, if the wave starts here, alright, these two enemy X positions are within the camera bounds, so therefore they must be part of this wave that we want to spawn. Easy as that. This is why I really like this system, because the computer figures it all out for you. What needs to go where and when. Alright, so spawn in the wave. So, if last wave is not equal to current wave. So basically what we're going to see, like, okay, this current wave that we're on hasn't been processed yet, because last wave is not equal to current wave. So what we're going to do is we're going to set the last wave equal to current wave, so that we only do this part once. And then what we're going to do is we're going to loop through our wave array. So another little detail, as you can see here, I start from the back of the array and loop downwards. That's because if we use array delete, it'll shift things in our list. So like, let's say, like, imagine a list, right? And an array is set up like a list. So like if we have apple, bread, oranges, whatever, right? If we were to go forward in this list and cross something off, then it would cause problems. So like if we want, like, okay, remove the second array, the second part of our list. So we'd remove bread. And then we could say something like, okay, remove the third part. Well, the computer's going to say, oh, there's no more third part left because, well, there's only 2 pieces to our list. Whereas if we loop through it backwards, like how we're doing on our for loop here, we can say, like, okay, delete the third option, delete. Delete the second option, delete. Delete the first option, delete. Easy as that. So that's how that works. That's why I'm going backwards here, because we're deleting here. So first we're going to pull that data out by storing it in E again. So this is going to check if the wave number of the object we're editing is equal to the current wave. If so, then we're going to create on this layer at the X and Y, which is stored by placing the object in the room, instances, which is the layer in the room that I want to spawn it on. You can also use depth here if you care, but it doesn't really matter to me. This layer part is like the least important part to me. And then object index. So this object index is important. Storing that value is important, because if you have different enemies that are different objects, like if I wanted to make a new enemy that was like, I don't know, big guy enemy or something like that, we could store that as the object index and create that specific type of object. So this here, this part that's all commented out, I just wanted to show you. So this here is what I use to edit object indexes. In my actual game, some things that I'm spawning in with the wave manager, like the spike ball, have different variables that work a different way. So for this spike ball, if I go into the room and find that there's a spike ball, then it stores a little bit more information, which is dir, because the spike ball is meant to go left or right, and this dir variable basically stores that. This doesn't matter for the tutorial at all. I just wanted to show you so that in the future, if you're like, oh, I need to figure out how to add a little bit more data, that's a way that you can do it. You can store different amounts of data and track it just based on the object index. But you don't need that, so I removed it. Alright, array delete. So this here will just remove things from the wave. So this will just make the list shorter until the list is empty. And then, yeah, so that's all that does. Alright, start the next wave. So what this is going to check is, this is going to get the instance number of all the enemy parents. So this will be like, okay, how many instances are there still around? If there are no more around, and there is a wave currently active, increase the current wave by 1. So this will just make sure that this part runs again. Easy as that. Alright, reactivate movement. So this will check the length of wave. So if the surviving enemies is 0, all the enemies are gone, and the array length is equal to 0, our array is completely exhausted, there's nothing left in it, then if we are locked in place and not lock camera, we're going to say locked in place is equal to false. We're going to free up the camera. We're going to set the front bounds to the room width, so all the way to the right, so that the camera can once again move to the right. And we're going to reset values, which is this here. Easy as that. So that is the entire enemy manager system. So how we're going to set that up is in our rm_persistent room. We're going to go there, and we're going to click and drag it in. And that way, we'll always know that when the room starts, our enemy manager is going to be there, and it's going to store all of this data. So there's a few more things we have to do. If you remember, I talked about setting up enemy parent. So let's go ahead and set that up. So we're going to create a new object called enemy parent. Now this parent, it's not going to do anything. Alright, it's not going to be there. The only purpose of this parent is to leave an inheritance for the children. So as you can see, any parent has no sprite. It has literally nothing. It has no events. It's not going to run any code at all. But if you click on parent here, parent, this will be no object, so it has no parent, but it does have children. So children is going to be obj_enemy. So how this works, in my game, every single enemy object, so like I have an enemy for the green guy, an enemy for the gray guy, an enemy for the yellow guy, blah, 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 blah. All of those are going to be children. So that way, whenever I refer to obj_enemy parent, Gamemaker knows, oh, he's not just referring to this singular obj_enemy. He's also referring to this entire group that are all enemies. So that's what I use this parent thing for. Just so that Gamemaker knows, oh, okay, you're referring to all the enemies. Right now it doesn't seem to do much because we only have one enemy set up. But if you have taken the time to set up more enemies, or if you want your beat 'em up game to have more than one enemy, this is how you can make sure that Gamemaker refers to every single one of your enemies in the same way. What else? Variable definitions. So if you click on variable definitions, you go down here. Wave_order. Default is 0. Integer is what the type is. So Gatsby, what does this do? Good question. What this does is this will store what wave the enemy is on. So we set this up in the parent because all the children are going to inherit this value. So if we go into our room and we double click on this guy. So remember, my main goal for setting up this system was that I wanted everything to be editable in the room. I wanted to control everything from the room. I didn't want to have to do things by memorizing numbers. So as you can see, this object right here, its wave order value is 2. So that means when our enemy manager comes in, it'll store, okay, this guy's wave order, this guy's wave number is going to be 2, because that's why I set it up in the room. And then when it comes in here and it's spawning in waves, it's going to be like, okay, is the wave number equal to the current wave? And then spawn that guy in. So as you can see, I could do something here where I just take this guy, Control C, Control V, Control V, Control V, and now wave 2 is going to have all of these guys. So by default, the first wave variables is 0, as you can see. And then I think this guy, is it this guy? Yeah, this guy is wave 1. So this guy will spawn in on wave 1. That guy will spawn in on wave 0. And then these guys will all spawn in on wave 2. So that's how that works. Very simple stuff. Alright, enemy parent. That's the enemy parent. Alright, so now what we need to do is we need to start the wave. So the way I have it set up is these blue bars are going to control where a wave is when the wave starts. Easy as that, right? So basically what I did is I created a new sprite called SBR Wave Starter. This doesn't really need to look pretty. This hitbox is not meant to be viewed by the player. I have it visible right now, just for yours and my convenience. But generally, this sprite shouldn't be visible. It should only be visible to you as the dev as you're editing things in the room. So I just have like a white box with a blue fill with wave on it. Just that I know that's what the thing is. All right. Now, the wave starter object. This is going to be very, very simple. We're going to add event, a collision event, with the player. So when the player runs into me, I'm going to destroy myself, and I'm going to activate wave by first locking the camera in place, setting the back bounds to the camera's X, setting the front bounds to the camera's X plus width, and we're going to tell the enemy manager, okay, it is time to activate the wave. So that's how that should work. And then yeah, that's all you need to do, and then you can just come in here and basically put this wave starter on the ground like, okay, this is where I want it, done. This is where I want the second one, done. Easy as that, right? You do have to be careful about where you put your enemies, because if you put your enemies like way off here on screen, you'll never see that enemy in the game. But this is basically how the system works. So another thing we have to do is we have to make sure that our enemies and our player is clamped to the bounds. And that is very, very simple. We're going to go to our player. And then we added, yeah, I believe just this line. Wait, no. I think this is from a previous tutorial. I'm pretty sure I went over how to make hitboxes. Is there anything else? Nope. Alright, so added this. X is equal to clamp, X, global.backbounds, global.frontbounds. So this keeps our X in between the back and front bounds values. And yeah, that should be the only line of code. This is from the update, from the uppercut code. I know this kind of draws back the curtain of how I do it. I'm a very professional YouTuber. But yeah, really, this is all you need. And then we also need to add that to our enemies. Basically, so something else, I believe I didn't leave, like, our enemies shouldn't die based on how I set them up from previous tutorials. So we'll probably need to add that as well. You'll probably need to add that. It's very simple stuff. So basically, HP is equal to 5. Added that. In our get hurt code, HP minus equals damage to do. All of that should be set up. I went ahead and added that for both our punch and thrown damage types. And then in step, if our HP is less than or equal to 0, instance destroy. There's ways to make this more complicated. So in my actual game, I have a death state. And basically what will happen is if HP is less than or equal to 0, it'll go to the death state. It'll hang around and animate for like a few seconds. And then it'll destroy itself. But this is just like the very bare bones sort of thing. If you want me to go more in depth with that system, I definitely can. But I definitely think that's something that you can do on your own. So I want to leave that open for you to do on your own. Alright, state machine. Blah, blah, blah. Shouldn't be much added here. Everything should pretty much stay the same. And then you'll look at this and you'll notice, oh, this is the exact same code that we added to the player object, and you are 100% correct. Well done. So, that should be everything. So now if we run the game, you should be able to see it working. So we should be able to run into this. We should be restricted by the global X and Y bounds. You can set up a clamp to keep the player within this little space here. I don't have it set up right now, but I mean, I just use a different clamp for that. But yeah, simple stuff. And then you can fight these enemies, and they should die. And now the wave has once again unlocked. And then we're going to hit that edge. We're going to play with that. Boom, boom, boom. Boom, boom, boom. Alright, and as you can see, 4 spawned in that time, which is the exact number that we set up. So we can go ahead and kick these guys. They should respect the room boundaries. Ow, ow, stop. My goodness. Well, there's a lot of them. They really hit. Okay, there we go. And they're dealt with. So yeah, that is basic level design stuff, basic wave generation stuff. Easy as that. What else do I want to go over today? I think that's pretty much it. Oh yeah, what I thought would be fun is, so if you notice, in my actual game, there's this sort of entry animation that they run. That's a little bit different than what I have set up here. Like, as you can see, they just like pop in as soon as they're spawned in. But in my beat 'em up game, they sort of run in. So I don't want to go too in depth with how that system works, but I'll just kind of show you what I do, and then sort of let you piece together the pieces yourself. So let's go ahead to my main project and can show you a bit of my main project code. Alright, so if we go in here, so when my wave spawner works, as you can see, enemies actually run into the scene. So we can see that again here. So as you can see, he comes in and he starts running and all that stuff. And yeah, so each time that happens, they run in. So you might be wondering, like, okay, Gatsby, well, how do you do that? Well, here's this little trick. These enemies, they look like they're running in, but they're always spawned at their exact position. So as you can see, those guys seem to appear when I clicked right there. That's because they were standing right here in the game, but they were just animating running in. So as soon as I hit them, they immediately snapped to their positions. So if we go into my enemies here, we have a lot of moving parts here. This guy. So what I have here in my game, footstep code, enter the scene. Wait, is this it? Yeah, okay. So what I have here is, do you remember our anim_x variable? Well, what I do with that is, this doesn't actually change the enemy's position, but it does change where it draws itself. So what I've done here is, basically, when my enemy is created, it starts drawing itself at the anim_x coordinate that's off screen. Basically, this calculates like, okay, are you to the left of the screen center or to the right of the screen center, and then enter from the appropriate side based on that. And then what we're going to do is, in our step event, we're going to start from the enter scene state. So let me see. As you can see, my current state is enter scene. So this enter scene state, all it does is it shows the animation of the enemy running in. So obviously our sprite index can be my sprites.run. This is just to play footprint sounds. This makes sure that we are facing the correct way when we are running in. And then our anim_x, I used an approach script for that. I don't know if I set that up in the tutorial, but you can look up what an approach script is. It is a very, very, very common script in Gamemaker Studio. All that does is that moves anim_x to 0 at a speed of 20. And then basically what we're going to do is like, okay, if our anim_x is less than or equal to 2, then we set our anim_x to 0. We no longer need to animate like that. We go to the idle state, and basically this allows us to This allows us to start running everything properly. So if you want an enter scene animation for your objects, this is basically how I did it. I just created a new state that would dictate how the object would enter the scene. I also made sure that like if they go to the hurt state, this anim underscore x is set back to 0. That way they don't their draw position is not off forever, right? I did it this way because I knew that later on in the game I would want things to come in different ways. So for example, for this pirate, he actually falls into the scene from the top of the screen. And so that way I have it set up in anim underscore y. So that's basically how I did it. Each enemy can animate into the scene a different way. Some beat 'em up games, you have them like kick down doors and enter through doors. Basically, it's going to depend on your game, and that's why I'm not really including it as an official part of the tutorial. I just want to draw back the curtain and show you how I do it in my game, so that way you can think about how you can do it in your game. So anyway, this has been how to spawn enemies into your game, the YouTube video tutorial for YouTube and for you. Thank you so much for watching. I hope you enjoyed just kind of seeing how the process works on my end. And I'm going to leave it there. Thank you so much for watching. Please like and subscribe. Please check out my beat 'em up game that's in the comments section linked. And until next time.